Hey guys, Will here. Welcome back to the channel. Now, first of all, I need to apologize for the amount of time that it's been since I've uploaded a video. It's been about 3 or 4 weeks now. The reason for that is my whole family's been pretty sick, so I had to have some surgery on my back to begin with. That's all good now, but I also had a really nasty flu. I was coughing and sneezing and my eyes were all puffy, and I really just couldn't make any videos. And then on top of that, the kids got sick as well, so they were in and out of hospital a couple of times and no sleep, and it's just been a disaster month for me. So apologies for no videos, but the good news is that everyone's back to full health again now. Back's all good, so we are good to start making some more videos. So today's topic is stability testing and how it relates to overclocking. So if you've ever overclocked a computer before, or you've looked at other people's results from overclocking, you would have seen that people refer to a machine as stable or unstable. And basically what that means is that the system is, well, it's what it says it is. It's stable. It's able to function without crashing or erroring out or blue screening or whatever. So basically where this gets complicated is stability is a bit of an arbitrary term. So what I mean by that is that stability to one person might not be stability to another person, and so forth. And there's no real sort of, I guess, yardstick for measuring exactly what a stable system looks like. So what that means is that when we are in a scenario where we get, say, a new CPU's released, everybody's overclocking it, everybody's posting their results on Reddit or in the forums or whatever, people are saying, oh yeah, I was able to reach 5.4 gigahertz stable, for example. What exactly does stable mean? And it's very difficult to compare between various different CPUs because of the silicon lottery factor to begin with. But when you add on top of that the fact that everybody tests stability a little bit differently, it really opens up this massive can of worms, and it makes it impossible to really know exactly what's going on. Now, thankfully, we do have systems like HardwareBot, whereby people can actually submit a verified result. And that's good in terms of verifying stability for a particular program, but it doesn't necessarily mean that a system as a whole is stable across the board for all tasks. So say, for example, you're overclocking to reach a result for, say, Cinebench. What'll happen is you'll get a stable overclock and run the maximum possible for a Cinebench result. You can verify that on HardwareBot and actually have a verified stable Cinebench result, but then you might go and run, say, RealBench, and it crashes immediately, or OCTT crashes immediately, or you might not be able to run a game or whatever. And the reason for that is that different programs place different types of loads, different types of instruction sets, different amounts of memory load and so forth on your system. So when we refer to a stable system without actually quantifying exactly how we've called it stable, it's really a bit of a meaningless statement. So what I want to do in this video is show you how I stability test a system, and the way that I wish everybody did it, so that we could actually compare apples with apples. So there's a couple of different factors in here. Obviously, the voltages that you're using, the temperatures that you're reaching, the type of cooling that you're using all come into play here. So what I want to do is show you exactly how I do it from start to finish. So we're assuming that the system is able to boot into Windows successfully. That's obviously the first point of stability, so to speak. And then from there, I'll show you the programs that I use to verify that stability, check our maximum temperatures, and so forth. Now, one thing that it's important to note is that just because you're stress testing a CPU or a memory controller or whatever doesn't necessarily mean that it's going to be 100% stable. And I actually came across a scenario exactly like this about a month ago now, where my system, when I ran a stress test, it was perfectly fine, everything was perfect, and then I'd walk away for an hour with it just idling. I'd come back and find a blue screen, or I might be writing an email and suddenly it would blue screen on me, and scratching my hair, tearing my hair out for weeks and almost months, I think it was, trying to figure out exactly what was going on. It turned out that it was an issue with the way I had the memory configured. I had the wrong DIMMs in the wrong slots on the motherboard, and it wasn't playing nicely with the other children. So basically what was happening is I was getting these random memory errors that were causing the system to crash. So the CPU itself was stable at the overclock, but the memory was causing issues. So when I'd load it beyond a certain point, it would cause issues. So there's all sorts of different things that you need to test to call a system completely stable. So let's jump in and I will show you exactly what I do. We'll jump up onto the screen here now. So the first thing I do, assuming that I've been able to get into Windows successfully, is I open up my Ada64 software. Now there is a free version of this software available, which is basically it's like a 1-month trial. Now this is software that I use all the time, so I do recommend that you pay for it, simply because it's brilliant software that works really well. So first thing I do is I click on computer, open up that menu, click on sensor. So you can see here listed, we've got our various different temperatures for motherboard, CPU, CPU package and so forth, all the various cores, the GPU. Temperature 1 in this case is my water temperature, my SSD temperature, and my hard drive temperature as well, which is an external hard drive which is currently plugged into the system. So a little bit meaningless, that one, but so forth. And then we've got the cooling fan RPMs as well as our voltages, which is obviously critically important as well. So you can see here I'm running 1.36 volts not under load, and then I'll open up CPU Z quickly for you as well. So you can see my my clock speeds. So we're running, just waiting for it to load up. Oh, we don't need to worry about updating right now. Okay, so we've got 1.36 volts under idle, and then we've got 5.1 gigahertz. Now, importantly, I don't have an AVX offset set up on this particular overclock. If you're interested to learn a little bit more about AVX offsets and all that sort of thing, check out my previous overclocking videos where I explain that in a bit more detail, as well as my videos that I did on setting up fan profiles and water pumps and that kind of thing as well. That'll give you a lot more information there. But basically, an AVX load is a different type of load, a different type of instruction set that loads the CPU a little bit differently. And typically an AVX load requires a little bit more voltage and generates quite a bit more heat as well. So if your system is stable with an AVX load, chances are it's going to be stable without. So the flip side to that is that sometimes you might have a non-AVX load that's completely stable with an overclock, and then when you introduce AVX, it becomes unstable. And that's where we can use an AVX offset to reach the maximum stable clock speed with non-AVX, and then ring that down a little bit or lower it down when we introduce AVX load to keep things stable. But in my case, no AVX offset here. So you can see when I start a stability test here in AIDA64, I've got my CPU, FPU, cache, and system memory all testing. Don't need to worry about GPU just yet because we're not testing that just yet. We'll jump back up to CPU Z. You can see here my core voltage actually jumps up to 1.376 under load. That's my load line calibration. And again, if you're wanting to understand a little bit more about load line calibration, check out my other overclocking videos. I'll link one of them above my head for you right now. But you can see here, under load, 5.1 gigahertz. And we'll close that off. You can see our temperatures are sitting at around sort of the 65 to 75 degree mark across the various different cores on the CPU. Again, we're only loading up the CPU and memory here, so we don't need to worry too much about GPU at this stage. We'll get into that a little bit later on in the video. And what we need to do here is obviously check immediately that it doesn't blue screen. AIDA64 is not particularly good at throwing errors. It will often pass a stability test where other programs will fail. So I generally just use this to establish basically a base point of a basically stable overclock and roughly what my temperatures are going to be for realistic kind of workloads. So rendering videos, playing games, these are the kind of temperatures that we're going to see under a realistic workload using AVX instructions. And a lot of stability programs like Prime 95, they really place the CPU under an unrealistic amount of load, which is fine if you want to test ultimate stability. If it can survive that, it can survive anything. But the reality is that in a real world scenario, you're rarely going to see, if ever going to see, those kinds of loads on your CPU. So I don't like to use those programs simply because I don't think they're painting a particularly accurate picture. So we start off with the AIDA64 test. I usually let this run for about 15 minutes just to let all of my temperatures reach their sort of maximum stable amount. Obviously, different systems are going to reach those temperatures at different points. On my particular system, it takes about 15 minutes for me to reach my maximum temperatures. So I let it run for about 15 minutes, assuming that it hasn't errored out, hasn't blue screened. We can establish that basically our system is essentially stable in Windows. Everything is going to be generally fine. So while we'll stop that now quickly. And what I like to do is leave all of this open, and then I jump into Cinebench, which I've got sitting over here. So we'll open that up. Now, Cinebench is a very popular one for stress testing and benchmarking CPUs in general. Move that across again. So what I do is I like to run Cinebench when we're stability testing here. Well, remember, we're stability testing, not benchmarking here. So my benchmark results are going to be lower because I've got all these various other programs open. But I like to run it while I've got this log open here so I can actually see what's going on with the load and temperatures and such. So we hit our run button for the CPU and the test will begin. And you can see, again, our temperatures will jump up. And we're getting around that sort of 65 to 75 degree mark, which again is perfectly fine. I don't like to see temperatures over about 85 degrees on the individual cores. The different CPUs will vary, and obviously if you're running a massive temperature spike up at around the sort of 95 to 100 degree mark, then the CPU will typically throttle down to protect itself. So you don't need to worry too much about temperatures, but I just like to keep an eye on things while I'm stability testing, because we want to make sure that if we ever got into a scenario where the CPU locked under 100% load while the machine was frozen or something like that, we're not going to cook the CPU with massive temperatures. So we can see here we passed Cinebench no problem. No errors. Obviously the score was very low because we've got all these other programs running in the background, but that doesn't matter here. So if we were only wanting to, submit a score for Cinebench at this point, what we would do is we'd close off all of our various other programs, boot up cleanly with Cinebench and run it until, run it maybe 3 or 4 times just to make sure it doesn't fail. Just run it once more. I know it's going to be stable on this system because this is completely stable, but we'll run it again just for the sake of it. So at this point, if you were competing for Cinebench, then you could say, yep, okay, my system is stable for Cinebench. That doesn't necessarily mean that the system is stable in all scenarios though. So if you're wanting to claim that your computer is completely stable, this isn't enough to say that that's the case. So we'll let this quickly finish here. So Cinebench is a really great program for testing overall CPU speed, but it doesn't place the CPU under the maximum amount of load. Now, even though the CPU usage is showing as 100%, which you can see here, what you can do is you can use programs which load the CPU up so it's not actually loading anything into the memory, and all it's using is just the data that's stored inside the cache. And that really stresses the CPU and causes, if it's going to fail, it's going to fail under those kinds of conditions. So that's the sort of testing that that Prime 95 and programs like that do. Now, I don't actually use Prime 95 anymore. I actually like to use Intel Burn Test because I find it tends to pick up errors without blue screening, which is great because it means you don't have to keep on going through the whole crash log thing and everything. So we load that up first. We start off with a standard package size, which is around the sort of 1 GB size. We hit start. And what this is doing is it's testing for a known result, testing it multiple times. So I like to run it through 10 individual loops. And you'll see on standard, it only takes maybe it depends on the speed of your CPU, but it only takes a few seconds to run each test. So we just sort of sit there and let that run through until it's finished all 10 loops. Again, you can see my CPU temperatures aren't going crazy high, so I'm perfectly happy with that, and nothing else is going crazy either. I'm not seeing crazy voltages on anything here, which is good. And again, if you're wanting to know what voltages are considered safe here, check out my previous videos where I've talked about overclocking voltages and all that sort of thing. So we can see here we're stable for 3. We're just going to let it sit through to the full 10. Okay, so we've passed the initial Intel burn test with 10 loops at around 6.5, 7 seconds of high load. And you can see here, obviously, the temperatures are spiking up and down depending on the amount of CPU load. So it's not a sustained load. So that doesn't really tell us, that tells us that the system is basically stable, but I'm not satisfied with that. What I like to do then is go to the very high setting, which increases the load to increases the memory usage to 4 GB instead of 1. And what that does is it basically sustains the same amount of load for 4 times as long. So we're looking at sort of, half a minute per test. If it passes that, then I usually go to maximum, which uses the maximum amount of RAM that you have available to test as well. And that can take up to, 5 or 6 minutes, depending on how much RAM you've got in your system to complete each loop. And that's a sustained load over that amount of time. So if we start one load now, I'm not going to run through the whole thing because obviously it's going to take a long time, but we usually let that run. You'll see it takes a while to load the data into the RAM, which is why the CPU is not spiking up just yet. And you can see the load here sort of hovering around that 98, 100%. And there we go. Now you can see the temperatures are coming up and it's going to sustain that heavy load. You can see the system sometimes will hang a little bit as well while it's doing this. And that's perfectly normal. It's just because it's under very heavy stress, and it's actually prioritizing the processing over drawing the desktop and stuff like that. So just because the system hangs a little bit while it's doing this doesn't necessarily mean that it's unstable at all. It will usually come back again. So we'll stop that quickly now. We're not going to run it through the full test, but normally I would let it run through 10 loops of this as well, just to make sure that everything's perfectly stable there. So at this point, if you're able to pass a maximum of 10 loops, you're pretty much guaranteed that your system's going to be stable for pretty much most things. So at this point, we're pretty happy that our memory and our CPU are stable, but we still haven't introduced a GPU load and factored in the heat that generates inside a system as well. So the next thing that I like to do after that, just to absolutely verify that the CPU and memory overclock is stable, is run OCCT. So we load that up. Okay, so basically we just use OCCT on the default settings. We'll just drag this a little bit bigger for you as well. So again, we've got our basic load and temperature gauges here for the various different things, as well as all the various different data that we saw in AIDA64 as well. So temperatures, maximum and minimums as well, which is cool. So I normally just leave this on the default settings, large data set, OCCT CPU test. You can do a LinPack test if you want, but I usually just leave it on OCCT because I find that it places a more realistic load on the CPU. So the reason I really like this program, we'll start a stress test now so you can see. So with the stress test running now, you can see the temperatures are pretty realistic. We're sort of sitting in that mid to high 50s into 60s range, which is much more typical of the kind of loads that you would see, or the kind of temperatures that you would see, you know, playing games or rendering videos and things like that. So I really like this program because it doesn't pump massive amounts of heat into the CPU, but at the same time, it does seem to pick up errors that other programs don't. So I've had cases where, you know, I've passed a Intel burn test completely, no problems at all, and then I've run OCCT and it fails within a couple of seconds. So what I like to do now is let this run basically as long as I can. So I usually will run it for at least 4 hours, typically overnight. So I'll run it overnight, keeping an eye on those temperatures again for the first hour or so, just to make sure that things don't go crazy. And if the system passes completely overnight, no problem, then I'm very, very, very satisfied that my overclock is stable in terms of the CPU and memory at least. So we'll stop that again now. You can see how that works. If it does throw an error, it also gives you this really cool summary. So we can see here we stopped, so the summaries come up. It gives you a summary of exactly what all your temperatures and stuff did as well. So we can see CPU usage was at 100% obviously the whole time. You can also look at your load line calibration values, voltages. So we'll have a look at our V-core voltage here. And you can see under load line calibration, it jumps up to 1.376, and then it sort of varies between that sort of range there. Now, importantly, because we're only using the motherboard to measure here, we're not getting a really, really fine scope of measurement, and it does tend to sort of fluctuate between those two values. So we can probably say that the actual voltage is somewhere between sort of 1.368, somewhere around there, but that's not really important here. So these logs are really useful to just sort of check that everything was working normally and there was no crazy spikes in voltage or temperature or anything through the duration of the test. So that's really valuable. Okay, so if OCCT is passed for you overnight, you're pretty much guaranteed a stable system, but there's one more thing that we do want to check just to make absolutely sure, and that is introducing GPU load into the system. Now, this is particularly important if you're running your GPU through a water block that is running in the same loop as your CPU water block as well, because it does introduce a lot more heat into the system. For example, on my system, which is an 8086K processor with a 1080 Ti graphics card, the 1080 Ti actually introduces almost 3 times the amount of overall heat into the system that the CPU does when it's under 100% load. So it's really important here that we've got a system that's stable under 100% load across both platforms. So the way I like to test this is I open up my stability test console in AIDA64 again, just to make sure that I can keep an eye on my temperatures. So we'll load that up again. And then I like to use RealBench. So RealBench is really good for placing a load on the CPU and GPU simultaneously. So we'll open up this, run as administrator, close here, drag this across, and bring the consoles across so you can see them. So we click on stress test here. Run it for, usually I like to do at least an hour. We don't need to test this overnight because we've already pretty much established that the CPU and memory is stable. We just want to make sure that introducing that extra heat doesn't create any instability. There are cases sometimes where a couple of degrees can mean the difference between a stable or an unstable CPU overclock when we're looking at that real upper level of maximum overclocks that are achievable with your particular chip. So we want to introduce the maximum amount of possible heat. We don't need to do it for a massive amount of time. We just need to do it until the point where we reach that level of stability where the temperatures sort of sit at the top and they don't get any hotter. So for me, that takes about 15 minutes. I like to stress test for about an hour in this case. If you really wanted to, you could do it overnight, but I don't really see the need. So we'll go 1 hour and we'll go 16 gigabytes because I got 32 gigabytes of RAM. So I like to use about half of the available RAM. And then what we will do is hit start. And you can see it opens up a bunch of consoles and the mouse is really, really laggy now. Hopefully the recording doesn't stop. But we can see here it's doing ray tracing, it's doing all kinds of things. But importantly, it's loaded up the GPU, which you can see is now sitting at 40 degrees. as well as the CPU. So we're running 100% load on both of those modules, and that is important because it's introducing the maximum amount of heat. And you can already see the CPU temps are a little bit higher than they were when we were running just OCCT, probably 10, maybe 5 to 10 degrees hotter. And this temperature will go up over the next 15 minutes as the system loads up and it gets hotter and hotter and hotter. So once I've passed an hour of this under maximum stress, that's the point where I say that my system's completely stable. As long as I don't have any issues with crashing when it's under idle or just everyday tasks and funny things like that, the system is completely stable. So I don't post on Reddit, I don't post on forums and things like that my system's stable until I've run through all of these things. So if you're wondering how I do it, that's how I do it. Ideally, I'd love it if everybody followed the same regime as I do. But obviously, if you're only competing for results in, say, Cinebench or results in 3D Mark, you only need to make sure that your system is stable for that particular program. So that's all that's required to submit results for that program. So that's the reason why stability can be a bit of an arbitrary term. It means different things to different people. But anyway, look, that's how I stability test. I wish everybody did it the same way, but they don't. So we need to have these discussions to sort of figure out what people are talking about when they say their system's stable. So the next time you see somebody post some crazy high overclock and say that it's stable, ask them the question, exactly how did you stability test it? What tests have you done to verify that stability? And, questions like that, because it's really important to understand these things. So, look, guys, I hope you found this video interesting and useful. If you have, please do hit the like button, hit the subscribe button and the notification button too, so you don't miss the next one. Got a bunch of videos coming up in the next couple of weeks, so stay tuned. Thank you very much for watching, and I will see you in the next video. Bye.